When you look at a brick wall, what do you see? Most people just see bricks. But if you know what to look for, you're seeing a carefully engineered pattern, a code that tells you everything about the wall's strength, its history, and the skill of the mason who built it. This pattern is the brick bond, and choosing the wrong one or laying it incorrectly can lead to a weak, unstable, and dangerous structure. So, what are the rules? How does a simple arrangement of bricks transform a pile of individual units into a monolithic, load-bearing wall? In this video, we're decoding the language of brickwork. We'll move from the most basic bonds to the most complex, explaining the structural logic behind each pattern, the secrets to identifying them, and the critical mistakes that can compromise an entire building. By the end, you'll not only be able to name these bonds, you'll understand the why behind them, making you a more knowledgeable architect, engineer, or builder. Let's start with the most fundamental principle of all brick bonding, the perpend. This is the vertical alignment of bricks, and the golden rule is that the vertical joint between two bricks, also known as the head joint, should never line up with the joint in the course above or below it. This continuous vertical line of weakness is called a straight joint or stacked joint, and it's the cardinal sin of bricklaying. The entire purpose of a bond is to stagger these joints, interlocking the bricks so that the wall acts as a single, cohesive unit, distributing loads evenly throughout its structure. This staggering, known as lapping, is what gives a bonded wall its incredible strength. A pro tip from master masons is the quarter lap rule. A good bond should overlap the brick below by at least 1/4 of its length. This ensures adequate load distribution and prevents the creation of a straight, continuous crack line. Now, let's look at the bonds themselves. Starting with the most common one in modern construction, the stretcher bond. This is the pattern you see on virtually every modern house with a cavity wall. It consists entirely of bricks laid with their long face, the stretcher, showing. Each brick is staggered by half its length relative to the course below. So why is this so popular? Because it's fast, economical, and perfect for single-leaf walls. Like the outer skin of a cavity wall system, which is primarily a weather barrier, not a primary load bearer. Its limitation is thickness. A stretcher bond wall is only one brick thick, about 102 millimeters, so it lacks the mass and inherent stability for major structural work. A common on-site mistake is to use stretcher bond for a garden retaining wall or a load-bearing pier. Without the interlocking depth of headers, it will be dangerously weak. When you need real structural strength, you move to the classic solid wall bonds, English bond and Flemish bond. These are used for walls that are at least one brick thick, around 115 millimeters. The English bond is the undisputed king of strength. It's a simple, robust pattern that alternates entire courses of stretchers with entire courses of headers. Headers are bricks laid with their short end facing out, and they are the key. They bind the two leaves of the wall together, creating a monolithic, incredibly strong structure that is highly resistant to damp penetration because of its sheer simplicity and power. English bond was the standard for bridges, warehouses, and fortifications. The Flemish bond is its more elegant cousin. Instead of alternating whole courses, each individual course alternates between stretchers and headers. This creates a more decorative and visually appealing pattern, while still very strong. It is generally considered slightly less robust than English bond because it creates more straight joints in any single vertical line. A pro tip for identifying them is simple. If you see alternating courses of stretchers and headers, it's English. If you see alternating bricks, stretcher, header, stretcher, header within a single course, it's Flemish. For specific applications, we have more specialized bonds. The header bond consists entirely of headers, with each course staggered. This creates a very thick wall. The full width of the brickhand is often used for curved walls, like arches or circular structures, because the short face of the header allows for a tighter radius. Then there's the stack bond, where all bricks are laid directly on top of one another, creating perfectly aligned vertical joints. This is a purely decorative bond and is structurally very weak. English garden wall bond and Flemish garden wall bond are variations that use a higher ratio of stretchers to headers to save cost while still providing some structural tie. For pure decoration, bonds like basket weave squares of bricks laid as headers and stretchers or herringbone bricks laid at 45-degree angles are used in paving or as feature panels. A critical drafting mistake is to specify a decorative bond like herringbone for a structural, load-bearing application without engineering the reinforcement and support. To summarize the key takeaways: 1. The purpose of bonding is to stagger vertical joints and interlock bricks for strength and stability. 2. Stretcher bond is for single-leaf, non-structural walls. Was it a complex decorative pattern or a structural repair on an old English bond wall? Your field stories are invaluable. If this guide to brick bonds has helped you see walls in a new light, please give this video a like and subscribe.